everybody, and welcome back to another episode of Maths. Well, there's still a ton to do with fractions. We haven't even started multiplying them yet, for example. So because of that, I'm going to be actually splitting up kind of the fractions into different sections. So there's going to be several checkpoints for these fractions videos. And so the first checkpoint for the fractions videos, that's going to be Fundamentals of Algebra checkpoint number 3, is going to be coming up pretty quick here, actually, maybe just within the next 3 or 4 videos or so. So we're getting close to that. But today we're going to kind of finish off this first section of fractions on a really important topic called ordering fractions. Right, so we know how to order things, and we know how to use what are called inequalities. So that's these symbols here, right? Less than, greater than, less than or equal to, greater than or equal to. And they basically just kind of give us information about if a number is bigger or smaller than it, right? So for example, 3 is less than 4, right? Or we could flip it around and say this is 4 is greater than 3, or we can change the order, right? And we could say 4 is greater than 3 like that, right? Basically, whatever the big side is pointing towards, that tells us which one is greater. So hopefully you already know that. So these ones are called strict inequalities. So that is where it is exclusively greater than or exclusively less than. And the ones with the line, those are greater than or equal to. So those aren't strict inequalities. So for example, 3 is less than 4. That also means 3 is less than or equal to 4, right? Because it's either less than or equal to. And in this case, it's less than, right? So it satisfies the less than or equal to part. So this is also a true statement. And we could also say something like 4 is less than or equal to 4, since, well, 4 is equal to itself, right? And this is less than or equal to, right? So it satisfies the or equal to aspect. So that's just a little review on inequalities. Hopefully you know that already. And we can also do this with decimals, right? Right, decimals are numbers as well. So we can say something like 1.1, that's strictly less than 1.12, right? Because 1.12, we can kind of think about this on the number line, right? If 1 is here, 1.1 is there, then 1.12 might be right there. So it is just a bit to the right of it. So basically, these kind of tell us if it's to the right or left of it on the number line. And this is also useful when it comes to negative numbers, because if I had something like negative 3.14, and I'm comparing it with negative 5, okay, both of these are negative, and 5 is a bigger magnitude. However, we still say negative 3.14 is greater than negative 5, because on the number line, right, so 1, 2, 3, 4, 5, on the number line, negative 5 is to the left of negative 3.14. So since this occurs after negative 5, we still say it's bigger, right? So this basically gives us an ordering for numbers on the number line. All right, so that's nothing new. But now where things get a little more interesting is, what does ordering look like when it comes to fractions? So how can we tell if one fraction is bigger than the other? And in some cases, it's going to be obvious. So for example, if two fractions have the same denominator, so let's say we have 1 over 7 versus 2 over 7, okay, it's pretty clear that the 2 over 7 should be the bigger one, right? Because its numerator is bigger than the other fraction, right? Here we're saying we have one piece of size 7th, here we're saying we have 2 pieces of size 7th, so clearly this is a bigger number, right? This will come afterwards on the number line. And if we deal with negatives, it's going to be the same kind of thing as we saw up here. So for example, let's say negative 5/6 versus negative 23 over 6. Okay, negative 23 is bigger in magnitude, but again, these are both negative, so we would say negative 5/6 is larger than negative 23 over 6. It just comes afterwards on the number line, right? Negative 23 over 6 would be somewhere over here, and then later on we'd get to negative 5 over 6. So we would order them that way. Right, so if they have the same denominator, it's pretty much just an extension of what we already know, where we're just comparing the numerators, so we're ultimately still comparing kind of these whole numbers. So we can summarize that as follows. If two fractions have the same denominator, you just have to compare their numerators as normal to see which one is bigger, right? Because the denominators, that's constant, so the only change, the only difference is occurring in the top part. So then another situation could be, what if they have the same numerator? Okay, so we're just holding a different piece of the fraction to be kind of the same. So what if we had something like 2/3 versus 2/5? Which one is bigger? So this is saying we have 2 pieces of size 1/3, and this one's saying we have 2 pieces of size 1/5. Well, what's going to help us is if we think about what is a fraction. A fraction is division, right? So here we can think about 2 over 3 is 2 being divided by 3. We're taking 2, splitting into 3 pieces. Here we can see 2 over 5 is being 2 divided by 5. We're taking 2 and splitting into 5 pieces. Which one is going to be bigger? Well, the 5 pieces that we're splitting 2 into, those pieces are going to be smaller, right? If we split a whole amount into thirds and we shade in 2 of those 3 pieces, and again, they're all equally sized pieces, versus if we split the same area into 5 pieces and shade in 2 of those pieces, right? Since these pieces are smaller, we're going to be getting a smaller amount shaded in. So we actually end up getting that if they're the same numerator, this 2/3 in this case is going to be larger because we're dividing by a smaller denominator. So a smaller denominator means you're dividing by a smaller amount, which means the pieces that you're getting are going to be bigger, right? You have to basically split your area up amongst less pieces, so each one of those pieces will have a larger area, right? We split this area up into 3 pieces. Each of those pieces have a larger area than these pieces over here. So we can write down that rule as well. So if two fractions have the same numerator, compare their denominators, and the bigger denominator will give smaller pieces, right? So another example, let's do 3 out of 7 versus 3 out of 2. So 2 is a smaller denominator, so that means these pieces are going to be bigger, so 3/7 is going to have to be smaller than 3/2. And if we were looking at negatives, so let's say something like negative 15 over 4 versus negative 15 over 7, same numerator, but the denominator, we see here that this 4 is smaller, right? So this is going to be a larger value overall, right? Because we are splitting it up into basically less pieces, right? We're only splitting this negative 15 up into 4 pieces versus 7 pieces. So this is going to be a larger value, but since it's negative, right? Bigger in the negative means more to the left, which means that because our less than and our greater than signs are just determining their ordering along the number line, we're going to actually get that this negative 15 over 7 is bigger because it's a smaller amount because of that larger denominator which we're dividing by. Right? You divide by a bigger number, you get a smaller answer. All right, so I hope that made sense. And now let's go on to just if you don't necessarily have the same denominator or same numerator. All right, so what if you had fractions like 2/3 and it was versus something like 4/5? So now we can't just go ahead and compare the numerators because, well, they don't have a constant denominator, and we can't just compare the denominators because they don't have a constant numerator. So we have to be a little more clever about this. So one thing that we could do is, well, we could just force them to have the same denominator by making a common denominator, right? So a common denominator of 3 and 5 is going to be 15, right? So 2/3, that becomes 10 over 15, right? Just multiplying the numerator and denominator both by 5. And then 4/5, that becomes 12 over 15. And then it becomes clear that this is the larger of the two fractions, right? Because the denominators are the same, so we're just comparing the numerators. So we are going to have the bigger number, the one more to the right on the number line, being 4/5. Now, we could also do this in a different way. So let's say we had 2/3 and 4/5. What if instead we made them have the same numerator, right? So 2/3, well, if we just multiply this fraction by 2 over 2, we get to 4 over 6. So now we're comparing 4 over 6 with 4 over 5, right? We have a constant numerator this time. So then we see, okay, which one has the smaller denominator? Well, 4/5 has the smaller denominator, right? Which means we're splitting this 4 up into less pieces, which means overall this is going to be a bigger amount, right? Right, dividing it by a bigger thing will make it smaller. So because that's the case, we get the same ordering, right? So you can use either method in order to compare the fractions if neither are the same, right? So let's try another one. Okay, so here we have negative 8/3, and here we have negative 14 over 17. So we could go ahead and compare these. So they're both negative, and they have completely different numerators and denominators. So we probably want to make either their numerators or their denominators the same. In order to make their numerators the same, well, 8 and 14 aren't really factors of each other like it was up here. Up here was really nice, right? 2 is a factor of 4, so we just multiplied it by 2. But we don't really have that luxury here, so we should probably just go ahead and make a common denominator. So the common denominator of 3 and 17, since they're co-prime, is just going to be their product. 17 times 3 will be 51. So we're going to be multiplying the numerator and denominator of this fraction by 17 each. So we're going to get negative 136 over 51. And this one here, we're going to be multiplying by 3. So this will give us negative 42 over 51. So we clearly see that this has the larger numerator, right? But again, they're negative. So because they're negative, this is going to be more to the left than this one here, right? It's larger in the negative direction, but we're ordering them on the number line. So negative 42 over 51 will be greater than negative 136 over 51. Now, there's even a faster way we could have done this one. And this is where you're just going to have to get a lot of practice and kind of intuition with numbers in order to start to see stuff like this. But 14, that's less than 17, right? So we know that this whole thing's size is going to be smaller than 1. And since they're negative, right, we know that this is basically going to be bigger than negative 1, right? Negative 14 over 17, right? If negative 1 is right here, negative 14 over 17 will be just a bit to the right of it. So it's going to be larger than it. But negative 8/3, 8 divided by 3, that's going to be something a little bit bigger than 2, right? So with the negatives, right, if negative 2 is over here, negative 8/3 is going to be a little bit after that, right? So purely just from noting that, okay, this is an improper fraction, and this is not an improper fraction, we can kind of just use this ordering here to see, okay, negative 8/3 is going to be less than negative 14 over 17, and we don't even have to worry about making the common denominator. But if you don't think about that, then the common denominator is like a nice surefire way of going about it. So the last type of problem you might get with these are some combo problems. So you'll often get something like a list of numbers, and you have to order the list. So it might look something like this. Okay, so you'll have a list of numbers, and notice some of them are decimals, right? So you just have to put them in order. All right, so the first one, this negative 4th, is easy, right? Because there's no other negatives to deal with, so that's going to be right to the left there. And then after that, okay, we have all of these to look at. So we have 1. Is anything less than 1? 3.2 isn't. 5/3, that's improper fraction, so that's bigger than 1. But 5 over 12, so that is definitely smaller than 1, right? So we have 5 over 12 right here. And then 1 is going to be next. Right? Because 5, the numerator is smaller than the denominator, so that division will be between 0 and 1. Okay, so now we have to look between 3.2 and 5/3. So one thing we can do for this is let's convert 3.2 into a fraction. We know how to do this, right? This is just 32 over 10. And we can simplify that down to 16 over 5. So now we got to compare 16 over 5 versus 5/3. So to do that, once again, let's make a common denominator. So the common denominator will be 15. So multiplying these each by 3, we get 48 over 15. And multiplying these each by 5, we're going to get 25 over 15. So we see now more clearly that they have a common denominator, that 16/5 is indeed larger than 5/3. So we'll have 5/3 next, and then we'll finish off with 16 over 5, which is the same as 3.2, right? So the question gave us 3.2, so we should probably write 3.2 there. Yeah, so basically with these combination questions, you might have to do a little bit of converting your decimals into fractions, or maybe it's easier if you have way more decimals than fractions, it might be easier to convert your fraction into a decimal and then order things that way. But basically you're just going to be kind of using some strategies with converting between fractions and decimals. So this is just a nice little quick one-off topic where we discuss how to basically order fractions, and it's a nice application of things like making common denominators, converting between fractions and decimals, and just getting comfortable manipulating fractions overall. Fractions are numbers, so that means we can order them, right? And now we know how to do that with confidence. So I'll see you for some practice in the next video, but until that video, you have a good one, you stay groovy, see you in the next episode.